Let's build a foundation. Hello, fellow makers, builders, and engineers. Today we're diving into making things right. In any workshop or factory, the goal is to create something that works perfectly every single time. The answer? A powerful methodology called Six Sigma. Six Sigma isn't just a buzzword. It's a data-driven way to hunt down and eliminate errors. A sigma measures how much a process deviates from perfection. Six Sigma means you're hitting the bullseye 99.96% of the time, just 3.4 defects per million. Imagine making 1,000,000 Lego bricks and only 3 or 4 have a flaw. In engineering, this level of quality is critical. Think car engines, airplane turbines, or medical implants. A single faulty part can mean disaster. Six Sigma builds quality into the DNA of manufacturing, ensuring reliability and safety. Control the inputs, and you control the output. So, how do we actually do Six Sigma? With a roadmap called CADMech: define, measure, analyze, improve, and control. Each step builds on the last, taking you from a vague problem to a precise, data-backed solution. For engineers, CADMech is our scientific method for the factory floor. Let's say you're making hydraulic pistons, and some are leaking. Instead of guessing, you define the problem, reduce leaks from 2% to less than 0.1% in 6 months. CADMech forces you to prove assumptions with data, not hunches. It's a repeatable process for achieving excellence, whether you're making microchips or ship engines. It removes emotion and politics from problem solving. At the end, you get a more efficient, reliable process. That's the power of Six Sigma. The first step, define, is all about clarity. You can't fix what you can't describe. Create a project charter problem, goal, and scope. For our pistons, the goal is to cut leak defects below 0.1%. Next, gather data to see how bad the problem is. Test a batch, log every leak, and analyze if your process can meet specs. Map out every step, assembly, testing, storage, to spot where things go wrong. Maybe O-rings are getting contaminated by metal dust. Reliable data is everything. Faulty measurements mean wasted effort. Tools like Gauge R&R ensure your data is trustworthy. Without good data, you're just guessing. Now comes the analyze phase. Time to find the root cause. Use the 5 whys to dig deep. Why are pistons leaking? O-ring damage? Why? Tool has sharp edges. Tools like fishbone diagrams help brainstorm all possible causes: manpower, machine, method, material. Use your data to test these theories and pinpoint the real culprit. In improve, you fix the root cause, redesign the tool, retrain operators, update procedures. Run a pilot test with the new method, build a batch, test for leaks, and see if the fix works. If the data proves it, you're ready to roll out the change. This step ensures your solution works before you invest in a full-scale change. It's the ultimate test before you trust. You've fixed the problem, but now you need to keep it fixed. The control phase locks in your gains and prevents backsliding. Use control charts to monitor the process. If data points drift, you catch issues early. Update documentation. New tools, procedures, and training become the standard. Create a control plan. Who monitors, how, and what to do if things go wrong. This keeps improvements in place, even if team members change. Six Sigma mastery is a huge advantage for engineers. It shows you can use data to drive real improvements and quality. Embrace it as a powerful tool in your engineering toolbox. Go out there, find the flaws, and build a better world, one data point at a time.